What I want to talk to you today is about the fact that solid-state lighting is a system. It's not an LED, it's not a driver, it's many different components that make up the whole solid-state lighting system. So for example, we've seen this slide many times. Basic elements that you need. You have electrical supply, the driver. You have some sort of thermal management. The simplest case is just a heatsink. More complicated case, you might add fans, you might add temperature, thermal management, things like that. You have connectors, all part of the system. You have the housing, it's got to look good. There's no point making a really nice, technically functional light that nobody buys because it looks ugly. And you've got to have the right LED, of course. And the right optics. So if you want to get a good LED light, you have to have all of these 6 different elements sorted out and done right. This makes it so difficult. If you're a LED manufacturer, you can do the housing well. If you're a lighting manufacturer, but understanding the LED, understanding the drivers is difficult. If you're good at doing drivers, understanding the mechanical side might be difficult, or the thermal side. So basically you need all of these different elements. A mechanical interface, a thermal interface, an electrical interface, a photometric interface to handle the light you're getting from the LED itself. So if you just look at the photometric, this is the lumens per watt efficacy. This is what the presentation from Cree talked a lot about, how the right color balance is, the color temperature, and the optics. So when you start off, you usually start with the LED. You choose what's the right color temperature, what's the right efficacy, how much light do I need. Sometimes you don't need a 20-watt light. Sometimes 10 watts is enough. It's too bright. And you've got to get the optics right. So that's where most people that are starting to build an LED light, that's where they start. But I must stress that this is just the start of the whole process. The mechanical interface is often overlooked. Too often it's done as the very last stage of the design. And it should really be very early on in the design. The LED has to be mounted correctly. If you don't mount it correctly, it'll overheat. If you can't get the heat out of the LED die into your heatsink, it won't work. How is it going to be mounted? Is it fixed on a track? Is it mounted on the ceiling? Is it some sort of screw and socket connection? And how is that going to affect your mechanical assembly? So you need to know and understand all of these parts before you can even begin to design your light. The thermal interface is really important. We'll hear later on from Steinbeis a bit more information about this. Basically, you have a thermal resistance. You can think of it as a resistance of how the heat gets from the source, which is the LED chip itself, through to the air, which is where you're getting rid of the heat. And each stage of the process, from the chip die to the chip body, from the body to the PCB if you're using a PCB, or directly to the heatsink if you're using the new system, from the heatsink to the air, each stage will have a thermal resistance. And then there's a heat transfer. This is the very simple equation. There's a different, the amount of heat you can transfer is effectively the efficiency times your area times the temperature difference. Temperature difference, so you don't know sometimes what the ambient temperature is going to be. It might be 25 degrees here in Europe. In India, it's certainly not going to be 25 degrees. But you need to know that before you can design your light. So you almost have to know where is your customer going to use this light before you can do the design. You may need air movers. Maybe your heatsink is enough. Maybe your thermal interface management is okay. The design you do in your simulation. But you need to know all of these points. It's very, very difficult to have all of these skills necessary in one organization. If you're just a lighting manufacturer, they don't usually have all of these different skills. It makes it much, much more tricky than designing a normal light. And finally, the electrical interface. what's your electrical supply? Is it constant current? Dimming control? Do we have any thermal feedback? Do we have any optical feedback? In some cases it's important that the light remains stable over the whole lifetime of the light. So you may want to measure the light level and keep it the same. And as obviously from Recon we make the drivers, I'm going to concentrate on the electrical interface, but it's closely linked to the choice of LED. And I'll explain that to more a bit later, why that's so important. If you look at a typical LED, this is the current that goes through it, and this is the voltage. So the problem is that when the voltage is below the point at which the LED starts to glow, nothing much happens, and then it goes very, very sharply up. You can see how steeply this curve is. This is in the current from 0 to 100%, the normalized current. This is in tenths of a volt almost. You can see how sensitive the LED is to very, very small changes in the control voltage. Trouble is, if you design a system that works like that, as the temperature changes, these curves shift. So when you're designing a driver to work with the LED, you have to know how will the LED characteristic change as it warms up, because the voltage is going to change. And now the new way of doing things with modular, with multiple chip LEDs, this effect is multiplied. Then you've got a choice. How do you do your electrical interface? Do you make it like a ballast? This is what lighting companies talk about, a lighting ballast. What they mean is it comes straight in with mains in on one end, constant current out at the other end, and it handles all of this changing that the LED does as it warms up. So there's nothing else for you to do. This is usually an external power supply, because it's physically large, because you've got to have a transformer to take the mains voltage down to the low voltage DC that the LED needs. But you can also do a constant voltage output and then follow it with LED drivers. It's also an option. Depends on how you're going to design your light. This may be a very efficient way for you to design a power supply, because these are usually larger, so you can mount them somewhere else, and these are smaller, so very nice and compact, so you can mount them in your light. So this would be a good solution, for example, for a track light system. You don't want to fit a big transformer in every single light. Fit one transformer or ballast, and then you control each one individually. Saves you a lot of money rather than trying to build a multiple output power supply that will drive 3 or 4 or 10 lights with 10 outputs. It's going to cost you too much money. So the design decisions you make are also the cost makes a lot of difference to the cost, of course. And you can either integrate them. Integrate them means you mount them on the same circuit board where your LEDs are. So we also have options, for example, where SMD mounting drivers to go, because most LEDs are SMD. So if you're doing a long strip light, you put your SMD process to do all of your LEDs. Then you want a driver that's also an SMD. You do it all in one process then. So we offer everything. We offer this part, we offer the through hole, we offer it with wires, and we offer it with SMD. So the difference between the two, if it's integrated, it's very compact. You can make sure that your power supply, your driver matches your LED very carefully. It's a single process and it's the lowest cost. But mounting a driver next to the hot LED is probably the worst possible place you can put a driver, because the LED might run at 50,000 hours or whatever when it's running at 85 degrees centigrade, but that's a very tough environment for an electronic driver. And the other problem is certification. By that I mean that you have to certify the whole system for EMI and stuff like that. So if you've got lots of separate systems all joined with long cables, trying to make sure that you don't have any EMI problems, no interference between the different systems, is quite tricky. You have external, You can set your LEDs how you like. You don't have to leave space on the board for the driver. You've got a flexible supply system, and it's the best place for a driver, away from the hot part of the design. And for the certification, we do that, so you don't have to worry about that. Our parts are UL certified, CE marked. We've done all the EMI stuff for you. So as far as you're concerned, it's an SEP, somebody else's problem, not yours. That's the main thing. A bit more expensive though, maybe. And it's a two-part construction. You need an LED system and a driver system, which is separate from one another. So it depends what you're trying to do with the light. So the first thing you have to check when you're designing it is, does the power supply match the LED string voltage and current? So normally you'd run a whole run of LEDs. So in this case we have 16 typically 1 watt LEDs. This is just an example. At 65 degrees centigrade, which is probably the operating temperature you've decided, you've got a forwarded voltage of 3.3 volts. You add it all up, you say, right, I need 350 milliamps at 53 volts, for example. So a good solution for this would be an AC/DC ballast, because you're underneath the 60 volt limit. However, you can take the same 16 LEDs and wire them up as 2 rows of 8, same amount of light. But now you've got 700 milliamps, double the current, half the voltage. So you might need a 2-channel driver here to make sure that the currents are balanced in each of these strings. Because if not, one's going to get brighter than the other. It's not going to look nice. These are the same LEDs every time. We can do 4 strings of 4. Now you've got 1.4 amps of drive current, but only 13.5 volts. So this is so difficult for us as a driver manufacturer to make the right drivers that match the right combinations, because these are all the same LEDs. 3 completely different solutions to what you need for the electrical interface.